AI Code Quality with Mark Seemann.
The AI DevOps podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that AI and Azure and the .NET ecosystem has to offer. Today, I have a repeat guest on the show, Mark Seemann, and he's a self-employed programmer and software architect based in Copenhagen, Denmark, and he's also the author of the book Code That Fits in Your Head and Dependency Injection Principles, Practices, and Patterns. And he's widely known throughout the .NET community for his Plo blog. We Americans have trouble saying that a bit. And on that blog, he's maintained that for years, writing about software architecture, test-driven development, and functional programming. And he shares his work and insights on GitHub and X. And he can also be found on LinkedIn. And Mark previously joined the show for episode 189, where we were talking about all the principles in his book, Code That Fits in Your Head. So, Mark, welcome back to the show. How are you, sir?
Thank you. I'm doing fine.
Awesome.
And it's good to be back.
Well, a lot has changed since then. Several years since you've been on the show, and everyone's been comprehending what's going on in the industry just in the past couple of years. But before we jump into that, for the people who have not heard you speak or listened to any of your podcast episodes, you go on other podcasts. You recently, in the last year, were on the .NET Rocks podcast as well. Just to get to know you a little bit for the listeners, if you go back in time, what is it about computers and making them do interesting things that grasped your imagination and has kept you energized in this industry for so long?
Yeah, I think I probably started like most of us, just being fascinated with being able to make the computer do my bidding, if you will. But I think what's really been interesting me, keeping me interested for the last couple of decades, is your ability to approach a problem from a lot of different directions. So this whole idea about having you have this particular problem and you can write it, and you can write a solution in different languages, but even in the same language, I've done a lot of C#. You can just go in so many directions and try to solve the same problem. You can really write a solution to a problem that gives you all sorts of problems in terms of coupling and maintainability. But you can also write the same, solution to the same problem in a way that actually allows you to move forward with, maintaining the code base and making changes to the code base and so on. So I've found that fascinating, and it's just the more I learn, the more languages I learn, and the more paradigms I learn. It just keeps, coming up with I keep discovering new ways to do the same thing. Basically, that's really fascinating.
Yeah, for sure. Well, we certainly have the way we read and wrote records to disk, 50 years ago is totally different from now, and so many other things.
Yeah.
Well, you wrote a book, Code That Fits in Your Head, which I still remember. I've read every chapter of that book, and is fascinating. If the listeners haven't thumbed through that, I'd recommend that. It's just a great way to think about how we think about code and all that. But since then, everybody has turned to AI tools to replace kind of the manual typing to whatever extent. And so from that book and one of your recent blog posts, does code quality still matter? How are you thinking about all those dynamics of what the code looks like and the characteristics that are desirable?
Yeah, that's an ongoing process, and I should say right up front that I have thoughts about this, but and they may sound like predictions, but I basically don't know what I'm talking about. At least I can't make any predictions. That's what I mean. It's really early days. So that particular blog post came up because of was basically just inspired by seeing some posts on social media by Tim Ottinger, and I also think Robert C. Martin had something to say about that. But Tim Ottinger was basically just asking the question of, if you let a software or large language model agent just go ahead and write a lot of code, and you don't really care about the code quality, then why do we allow that to write all sort of slop, if we will, if we don't allow people to do that? Mm-hmm. And that made me think about, okay, so does it really matter anymore? Because Robert C. Martin at the same time was doing a lot of posts on Twitter about, all his experiments with agentic coding. And then he was basically going in the direction where he said, well, I don't really look at the code anymore. He doesn't look at the code anymore. He still does some review, but not really at a detailed line-by-line level anymore. And so I started thinking about, okay, so does that sound reasonable? And I can't really figure out exactly, if it does, but I suppose it's, we can get back to this, but I think, we're probably going to see a divergence in ways of writing software. Mm-hmm. But, if you take the current situation where you have all of these systems writing code in, at a speed where you can't really keep up as a reviewer, it makes sense to sort of take a step back and say, okay, so if we can't really keep up as a reviewer, then why does it even matter that we look at the code anymore? Maybe we should just find other ways of verifying whether the software works correctly or not. And then I thought, okay, so, but if that's true, if we basically step away and don't really touch the code anymore, if we only let large language models work with the code base, then the traditional approach to having code quality, the question is whether that actually makes sense anymore, because code quality is something that we've invented, or we've figured out, we've defined all of these good practices for how we write software, because they deal with all sorts of limitations of human cognition. And if you don't have a human actually looking at the code anymore, then why does it matter? So that was sort of the question that I was trying to answer there. And
it's a very futuristic question about, are we going to have humans looking at the code? Because the technology is so far from that reality. The futurists who kind of convinced some companies to lay off software engineers because, AI was going to do it all. And then they're realizing, oh, shoot, no, that it can't actually happen. It's still, AI is still just a computer program. It still has to be operated by somebody that knows what it's doing. So the future of, are we going to look at it? Well, that wouldn't that argument be an argument for just doing it all in assembly language? If we're not going to look at it, then why are we even messing with high-level languages in the first place? And then that argument seems to fall down.
Right. So that's a little bit of a different argument, and I've discussed that in the blog post as well. So I think, first of all, I don't think it makes sense to write in assembly language, because we probably want systems that can cross-compile. So one of the things that assembly languages is that they're very specific to a particular processor. Mm-hmm. So at the very least, if we want to have some sort of deterministic process, if we want to write, source code that can be running on multiple different software architectures, we need some sort of language that is at a little bit of a higher level. So you could argue for that, from that perspective, you could say, so we need at least to write in C, because then we can cross-compile to different, processor architectures. But that sort of turns out that, that's an interesting observation, I think, because there are properties about programming languages that really have nothing to do with humans or human cognition, because they actually have some different characteristics. So, for example, C is a language that compiles to lots of different, processors. Mm-hmm. So we could say, okay, so if that's the case, are there other properties about programming languages that are not strictly for human ergonomic reasons, but they properties that exist for some other reason. And I think definitely you can find that, because you can have some languages come with very effective linters, for example. So you might want to take advantage of that ecosystem to make sure that you don't do super stupid things. And then again, you can say, well, why not take that why not take it one step further and say, well, okay, so some languages come with static type systems. And again, static type systems prevent you from making certain mistakes that, you can make all sorts of very, very, basic mistakes in assembly language or even in C that, a good type system can prevent you from. So maybe there's something to be gained there. I don't really know where this is going. Some people have argued with me. I have some readers that I should respond to that I haven't had time to get around to yet. But one reader says, yeah, but one of the things about large language models and the way they work is that they're trained on lots of data, and they're just trained on lots of Python code and lots of JavaScript code, and obviously also some C and C++, but all the languages that already exist.
Mm-hmm.
So we would probably expect to see them, even in the future, we expect these systems to write in those, one of those languages, and probably not just one of them, but, a plethora of those languages. But I think it's an interesting thought experiment to say, well, but what if we invented languages that were specifically designed for, not humans, but for computer systems to write instead? Because a lot of the things we do with programming languages so far has also been about ergonomics. How difficult is it to write the code? How verbose is it, and so on. And in a sense, you could claim, or you could make the thought experiment that you could say, well, does a large language model really care whether a programming language is verbose? And I'm not sure that it really does. So maybe we could design a language that's more verbose, but also type safe in all sorts of different ways, and also, more rigid in the sense of what's idiomatic and what's not. For example, we know that in C#, for example, there's multiple ways of doing the same things, and also because the language has been evolving for so many years.
Mm-hmm.
You have the old feature for doing a thing, and you have the new feature, and the very new feature for doing the exact same thing, and lots of different idioms that has sprung up around all of those different ways of doing things. And maybe that's not a good idea if we want to have large language models write our code instead. So maybe we should also think about having new languages that are more, where there's only one way of doing things, more rigid in that sense. And maybe that would work. So I don't really know. But then, one of my readers says, well, yeah, but you can't really come and invent a new language because there's no training data if you invent a new language, and then the models wouldn't be able to pick up on how to write that. And I'm not sure that that's entirely true, but there's a point there. So I don't know. I would love to see a future where if we have to give up control ourselves and let the systems do it, at least they would write in a language that had a lot of self-checking built in, like a really strong type system and so on.
Mm-hmm.
But based on my experience with all the stupid things people do, it's probably going to be JavaScript and Python. Yeah.
So
we'll see. We'll see.
And who knows what the future may hold? But
Yeah.
For this year and next year, it seems like that is not a good idea to have code in our Git repository that we don't understand.
Mm-hmm. Yeah. No, but that's probably a different. It's probably a little bit of a different discussion, because if you think about it, we are now, as programmers, we are just being put into the position that our product managers were in all along. We had program managers or product managers or whatever you call them, that were non-technical, but still had to trust us, the programmers, to do the right thing, because they didn't really have any way of verifying whether we did the right thing. Well, they could do casual, testing at the user interface. But they basically had to trust us. So now we're just in the position that other people were in all along. And I think the fundamental difference here is that when you decide to trust a programmer to do the right thing, you know that that programmer has skin in the game, in the sense that you can fire that person if he or she does not live up to your expectations, or if they do something that is, demonstrably, malign, if you will. But what are you going to do with a large language model? Can you punish it? You don't even know what it wants. So we have a problem with that. That's, and basically that's known as the alignment problem. So I'm still thinking about that. I can't really figure out what the answer is. I suppose it's going to be something like, again, human nature being human nature. I can, I could come up with all sorts of predictions about what could go wrong with using a large language model. But I think the allure of these systems are already so great that people are just going to forge ahead and use them anyway. And we will see cars running over pedestrians and elevators getting stuck, and medication systems, giving people the wrong medication, and people will die and be maimed, and all sorts of horrible things will happen. But probably not with a large enough frequency that anyone really cares, if I may be so cynical. And again, we have to acknowledge that humans are not, perfect either. We have plenty of those examples in the history of software already, where things have gone horribly wrong. So maybe it's like there's this argument about self-driving cars where they say, well, they're not going to be perfect, but they might actually turn out to be safer than human drivers. And maybe you can apply the same argument to code created by large language models. I don't know yet. I haven't really seen something, I haven't seen something very convincing that that's the case yet. But again, things are moving very fast, so we may see that in the future. Yeah.
Well, I was reading some survey results, and I'll find the link and put it in the show notes, about the AI generated code leading to somewhere around 80% more duplicated code and about 40% greater instability in production. And I think everybody's used it, witnessed the duplication where you just have more duplicated code, and over time, whether it be the solid principles, the don't repeat yourself, the dry principle, don't repeat yourself. We've learned that, you know what? It's actually not a good thing to have the same chunk of code in multiple places, or even just, magic strings, duplicating just a string in various places. We've learned that it's not a good idea. And so why would it be okay? Why would the author of the code, well, if we're machine generated code, why would it be okay then, and it's not okay for us?
It's so duplicated code is actually a pretty good example when if we come back to this question about code quality, because the reason why code duplication is dangerous is that we humans quickly lose track of all the places that we've duplicated the code. So, we write the code one place and then we have it another place and so on. And, all of a sudden we have it 20 different places with slight variations. And maybe it was even a result of more people doing, more than one person doing that. So from a cognitive perspective, the problem then becomes if you figure out that you need to change some of that code that's been duplicated, maybe you find a little bug in it, or maybe you just need to make a modification because requirements changed. Then you go and you edit 15 of those, but you have 20 cases of duplication, so you forget to correct 5 of them. The way that I understand large language models at the moment is that they also have some sort of limited working memory, if you will, and I believe they called it the context window.
Mm-hmm.
But I don't know whether that's going to change, or if that is a fundamental, limitation of that way of doing, artificial intelligence. That I'm not really that much into the details of that. But if we imagine that human cognition or the limitations on memory are different in a large language model or its predecessor, or what comes next, then it might actually, we could hypothetically imagine a system that could actually just always remember all of those 20 instances of duplication. And then, if we wanted to change how those 20 instances of duplication, how they worked, or fix a defect, it would just go and hit all of them, and it would always remember to find all of them and make the changes consistently across all the duplicated code. And if that hypothetical scenario plays out in that way, then that means that kind of code quality no longer matters. So that's basically what I mean by my question: does code quality matters? Does it matter? It's really a question of what can these new systems do? How and what I probably think will happen is that there will be some things concerned with code quality that doesn't matter anymore, because these systems are different, and we haven't really learned in exactly which ways they're different yet. But I think we're probably going to pick up on that in the next couple of years. But there will probably be things where it doesn't matter anymore. And then there will be, I guess, new things where we never really thought about a particular problem, but then it turns out to be a problem for these systems because they're just different. And, that's a very vague prediction, because I don't know what that will be at all, but I wouldn't be surprised if we would see something like that happening. So, I think, so the bottom line is code quality is probably still going to matter, but may not be the, your dad's code quality, if you will. Well, I'm an old man now, but
we're all old.
My code quality.
It seems like the interface point, the user interface for the computer continues to is what matters, and for developers, the lines of code have been the interface for us as a user of code editors and the Git repository. We're storing code in our chosen language in the Git repository, presumably because those are our documents, every code file. And so if we were no longer the audience, okay, well, it doesn't matter what those are, then maybe they should just be, I don't know, binary files or something, because we're not going to look at them anyway. I mean, in some regards, architecture portability is more important than us actually looking at them. But you also mentioned earlier the review burden. We generate code and then you have to review it. And so let's presume that we determined what our definition of good code is. We still have to make sure that it's good. It seems like other industries have automated so much work that we should be learning from them, like the assembly lines in factories. There was a time in industrialization where a person's hand was put on every piece of raw material, but now we have machines that do everything. Like individual workstations are highly automated, and then the factories are a sequence of machines where the materials flow through, and so to some extent, if a machine breaks down, we don't go inside the machine. We say, hey, I need an expert to come in here. Or we say, oh, replace the machine. It's not doing the right thing, as opposed to understanding why it's not doing the right thing. And so for the highly automated things where it's gone for so long, we haven't had to look under the covers. I think we get comfortable with the process having a black box. Or if I print a circuit board in a building in my own house, even if it's hidden in the walls, I know that I could look at the wire between a switch and a light bulb, and I could see, that's where the connection is. But as that compresses, we have printed circuit boards. I don't have any mechanism to even see, where all these little tiny electrical connections are. I just know that, you know what, if it messes up, I'm just going to get a different circuit board, or even it can be a different motherboard. I'm not going to diagnose my own motherboard. I'm just going to get a different motherboard.
No. That's true. But I think the old world, or the world that we're still used to, and also the example you gave with the circuit board is there's still someone who designed that. So you could say, well, that's basically just how specialization works, because you can't do everything. You can't be a high-level programmer and also be a circuit board designer.
Yeah.
But you knew that, or you still know that, if it's really, really important, you can still take that circuit board to someone, or in theory at least, and then have them look at what's wrong with it. And maybe you can't fix if you can't fix a circuit board, but maybe you can design an upgraded version of it or something like that. The circuit board is probably a little bit of a stretch already, because it's so complicated that no single person can do that. But
they're disposable at this point. We don't fix them. We replace them.
No. That's true. That's true. But what I mean is more that if there's a problem that's not wear and tear, if there's a problem with the way that it was originally created, I suppose there's still somewhere you can go, and an organization you can contact, and you can make them react to that problem that was in their product, and have them sort of fix that. And I suppose you could still do that with an LLM. I really have to admit, if you'd given me that assembly line metaphor, 3 or 4 years ago, I would have, I would probably have challenged that assumption, because I think programming is so fundamentally different from manufacturing, because programming is design. It's not, the bottleneck is not how fast you can type.
Right.
The bottleneck is not really how fast the compiler is, or how fast you can, upload a new version of your software to the cloud so that it runs there and you can do a new deployment. That's not really the bottleneck. The bottleneck is, or used to be thinking. So 3 or 4 years ago, I would have had, objections to that analogy. But now I don't really know anymore, because it seems like it actually is becoming more like a manufacturing process. Yeah.
Well, we've had
so you have
Kanban board. The Kanban board is kind of like this visual representation of the set of steps.
Yeah. But I think if we want to go in that direction, we need to figure out how to verify the product. There are ways we can build in quality, but there are still also, I think, I keep coming back to this problem of alignment, and it's not that I think that large language models are deliberately, evil or have our worst interest in mind. It's more like, I think, well, the more advanced they become, the more alien they become as well, and sooner or later you will end up with some system where you don't really know what motivates it. And you can say, well, Mark, now you're anthropomorphizing, because, who knows whether large language models have, motivations. But then again, they passed the Turing test a long time ago already. So in many senses, you are already dealing with an entity that sort of looks like it has a motivations. And whether or not you call it motivations, or you just call it weight in a model, it still determines that, some sort of bias in the way that it behaves. And that's my main concern. The more alien it becomes, the less we're going to be able to, understand what actually motivates it, or the bias it has in the way that it behaves. And that's probably just me being paranoid, I suppose.
Yeah. Well, it certainly is a fantastic simulation of something that might actually be thinking. We have to realize, no, there's no thought. We're just mimicking this neuron structure that we've kind of observed about our own brains and animals' brains, and guess what? If we mimic that structure, oh wow, we found a language simulator that's incredibly useful, but you turn the computer off and it's gone.
Well, of course, if you turn it off, it's gone. Yeah, but again, it's well, this is a completely different discussion because there are people who already discuss whether that's actually ethical. Because are you then killing it? Yeah. But that's a different discussion. I'm trying to remember. I was actually listening to podcasts recently where they were. Serious people were actually discussing this. I think it was on Sam Harris's one of his recent podcasts. Yeah, I can try to dig it up for you later
Oh,
if you
that's
will.
yeah.
But
So well,
yeah.
so I want to get back to reviewing,
Mhm.
outpacing
Yep.
review, and it made me think about the Toyota production system.
Oh,
Mr.
yeah.
Ono, the book from I think it was it 1978 or 1982, somewhere around that era when that book came
Mhm.
out, and one of the huge concepts that have been adapted to lean software development and agile and extreme programming 25 years ago, and the whole concept of if bad quality is going down the line, just stop the line, fix the source. Don't just have something later on to fix a problem. Let's prevent the problem from being created. Let's prevent
Yeah.
the rework. And so
Mhm.
this concept of AI code having to be reviewed by a person, and then we're going to
Yeah.
fix the problems that are there. That seems like that would be just totally ignoring a huge lesson that we've learned as an industry, that the right approach is to have every step push good work to the next step, not
Mhm.
add a certain step later on that corrects
Yeah.
the bad work that we've allowed to go down there. How do you wrestle with that?
Well, I think there's some things that there are things we can do right now, and there are things we should probably consider doing, in the near future. But I think if we can get the system to do, test-driven development, that would actually improve things a little bit, because the thing about test-driven development is it's sort of like the nearest thing in software development we actually get to the scientific method, because it's this whole idea about you have some sort of hypothesis and you want to subject that hypothesis to some sort of falsifiable tests. And the thing about just having automated tests in general, because I hear lots of people who say, well, I'm just going to let the LLM write tests for me as well. But then how do we know whether the tests work?
Yeah.
But the thing about TDD is that you write a test and your hypothesis is that it's going to fail, and then you run the test. And then, if the test actually passes, you've now falsified your hypothesis, and then you have to conclude that the test is not good enough.
Mm-hmm.
On the other hand, if the test actually fails at that point, you can't conclude that it's perfect, but you have reason to believe that it's probably doing the right thing.
Mm-hmm.
Because you also did some review of it and so on, or when you still wrote code yourself, you actually had some intent by writing the lines of code. But still, it gives you some sort of signal that it's probably not completely wrong if it actually starts out being read. And then you switch over and write the implementation, and then now you have a new hypothesis, and that hypothesis is, well, if I now run the same test, it should switch from red to green. And again, if that doesn't happen, you falsified your hypothesis again. So that's a very scientific method, which is sort of the best epistemological approach that we have to knowledge in general. So if you could sort of force LLMs into that kind of process, I think that would actually help quite a bit. And I was just talking a little bit earlier today with Dave Thomas, the F# Dave Thomas. There's a lot of Dave Thomases, and he said he was working with a system he calls Quartet. I think is one of something he did himself, but it sounded a little bit like that, because he had multiple agents where each had a different role, and one had the role of writing something like a test or a specification, and then the other one would actually be writing the implementation. And I've heard other people talking about agent swarms or whatever they call it. I'm not really up to date with all of the nomenclature, if you will, but that sort of approach where you are very disciplined in first testing one hypothesis and then testing the other hypothesis and going back and forth there. That would help a little bit, I think. That's probably in the near future. I'm not sure we have something that deterministically does that yet, but that's definitely something I would look towards if that was possible.
Yeah.
Then there's some other things we can do, because again, we want to have, if we still want to have some sort of human in the loop in terms of review, we want to have a lot of, if you were the reviewer, but you get lots of pull requests from LLMs every day, you want to have tools that you can run that will flag anything that's automatable. Anything you could automate, you wouldn't spend time actually doing that. So one thing I could also imagine is that first of all, you can measure. You can start out by measuring code coverage, and I know we've in the industry. So here's another thing where things are changing a little bit, because we've always said in the industry, well, code coverage is really not a quality measure, and
unless
I
it's
agree.
zero.
Yeah, exactly. But on the other hand, if you can just ask large language models to write all the tests that you need, you could set a fairly high bar and say, well, if what you give me does not have, let's say, 95% code coverage, then you should do better. So we could do that. We could say, okay, we're just going to reject this because you only have 90% code coverage. Go and fix that before you bother me again. So that's one thing. And then, code coverage in itself is not really that good of a measure, but it's just like a bar you have to pass. But then, you still want to know whether the tests are actually testing anything real, if you will. So another thing you could, I think, would be very useful is to do a lot of mutation testing. I don't know if you are nodding in the way where you know what it is, but do we assume every listener knows what it is?
That's great. Well, I mean, young programmers are coming into the industry all the time. Yeah. So a portion of this audience has no idea what we're talking about.
No, but let's just do a 1 minute, recap of mutation testing. But so basically, the idea is that there's a lot of small changes you could make in your production code that could, that should affect how the system behaves. So, for a very common thing you do in mutation testing is you change, a greater than operator to a greater than or equal. And then there should be some sort of test that hits that edge case. So if you have a test of that edge case, you should now have a failing test because you're deliberately mutating the production code. But then on the other hand, if you can mutate or sabotage your production code and all the tests are still green, that tells you something about how good the test suite is. And if you should probably not expect even a very good test suite to be entirely safe in terms of mutation testing. But so you'd probably still find a couple of, they call it mutants, where you can make changes to the production code and no test will find it, even with a good test suite. But I think that might still be an interesting way of doing some deterministic review, in the sense where you could say, before you even bother me, the human, with a review, let's just do a lot of mutation testing on this new pull request. And if you find more than some threshold of mutants, then just feed it back into the LLM and say you need to add better tests. So you can have things like that, and you can run, of course, automatic linters and make sure that all compiler warnings treat as errors, and things like that's low hanging fruits. But why not take advantage of everything that's there, if you will.
Yeah. So the listeners out there who have test suites that take many, many minutes, they're not ready to even think about that. A dependency is, you have to have a true good unit test suite that runs in seconds, not minutes or hours.
That's true. Yeah, and mutation testing actually takes a lot of time because you basically can imagine this system is going to run through your entire code base, and every time it finds a greater than or greater than equal or something like that, it's going to make a change, run your entire test suite, and see if there's any test that's failing, and then it's going to move on to the next thing it can change. So even with a good test suite, I've tried this with just medium-sized systems, and they just run. Mutation testing can easily run for hours, and of course, if then as you mentioned, if you have a test suite that takes 10, 20 minutes, then mutation testing is going to take days at least. Yeah, so that actually speaks to a good old software engineering best practice or good practice, and that is first of all, see what you can do in terms of making sure that the test runs as fast as possible. But there will be tests that are slow for various different reasons. So I think it's really good practice to have, if that happens, have sort of like tiered tests, or sort of like a staircase of tests, if you will, where I call them, the fast one, I typically call them developer tests, because that's what I want to have. That, if I sit in a TDD, cycle, test-driven development cycle, I want to have a test suite that can run in just a few seconds. So that would be sort of my tier one, or the first priority, my developer test suite. And then you can have another test suite that you can run with some command line switch or something, where once you're done with all the work, you can run it, and then that takes 10 minutes or several hours even, if that's the case.
See, that seems like a more objective way to talk about code quality, because this seems upstream. If we have poor code quality in the source, then what we're saying is, I predict that there will be production instability. I predict that somebody will have a hard time using the software, or will try to put in a feature in the future, and I predict that feature will be harder to put in later. It seems like it's all about prediction, and then someone can say, well, I disagree. And then how do you talk about code quality? But it seems like the tests, that is, it's less opinion. It's subjective. It's like, well, unless you can tell me which one of these test cases is wrong, then this body of tests, if all of these tests pass, then all of the individual chunks of functionality in the software are working as they intended. And then you could say, I'm missing a test. Like, do we actually have a test that throws, 10,000 concurrent transactions at it to see if it can handle 10,000 at the same time? Because in production, we've said that we want it to handle 10,000 at the same time. I mean, you could say you're missing a test case, but it seems like that's a really good objective way to go about it.
Yeah. But and now that you mention it, it reminds me of something that we've completely forgotten about, not only in this discussion, but I think the most of the industry in general seems to be forgetting about this thing about security, because it's not only about writing a system that works well. It's not only about making sure that all the required features are working as intended, but you also want to prevent bad actors coming in and taking over your system or abusing it in different ways. And that's a much, much harder, thing to test for, because how do you test that a system is not vulnerable to some sort of weird attack that you had never heard about before? You can't really do that. It's almost like those unknown unknowns that we always laugh about a little bit, but that's a really interesting epistemological category, if you will.
Yeah. Well, but at the same time, I think a lot of developers out there, it's one thing to say, oh, but have you gotten to this level of maturity? But I think a whole lot of teams out there still have gaps in some of the fundamentals. Like you mentioned security. Okay, it's one thing to say, do you think it's ever possible that somebody would be able to abuse your system? That's one thing. But then pull way back and say, and if you look at all the code bases, how many code bases are not using any kind of code scanning tool. I mean, just a quick Google search. There's a list, a mile long of tools that you could be using to do some scanning, some testing, some basic level commodity, penetration testing, just to cover yourself from the basics. And then from the basics perspective, then you could ask the question, I wonder what other surface areas might people attack. But I think a lot of teams haven't even filled in their fundamentals.
No, that's true. And also, if you go with this argument that the systems, the LLMs are trained on existing code that they've found all over, SQL injection is still number 4 on the OWASP top 10.
That's right.
So there's a lot of that out there. So and if you're not going to look at the code anymore because you're not going to review the code anymore, as Robert C. Martin suggests, how many SQL injection backdoors are you actually adding in your code because it was trained on that?
Because most code does not pass the OWASP top 10, and the LLMs are trained on just the average code.
Exactly, yeah,
right.
And I think sometimes we forget that because we're at this phase, at least in our, collective enthusiasm for, all the things that these systems can do, we are so focused on, or the industry is so focused on just, it can do all of these things, and it looks like the software is actually working as intended.
Mm-hmm.
But then again, you can do manual testing from today and until next year, and everything is working great, but you're never going to know whether there's a SQL injection vulnerability in the system until someone actually tries to exploit it.
Right.
Yeah.
Well, I would contend that if you tell an engineer you are responsible for reviewing all of this code to make sure that this code is good, I would contend to you that actually won't happen. Because if you put a real engineer in the place and says, I've been made responsible for this. I've been told I have to do this. I don't want to do it. They're going to build, an engineer is going to build a system that causes that to happen without him actually manually doing it. And then now, because you've made him responsible, he builds a system that verifies and makes it happen, but without doing what he doesn't want to constantly do himself.
Yeah, so you could definitely imagine a linter that looks for, obvious SQL injection vulnerabilities in different languages. Absolutely, yeah. Yeah, so probably it might be that we can solve these problems. This discussion is actually making me think about new directions that we can go in as well. So that's a good point. Yeah, it's very new, all of it.
Yeah,
and
it's an exciting time in our industry, though. I mean, I was very, very young when America Online and when email started to become popular, and when the internet, when it was like when businesses said, do I need a website? Why do I need a website? I'm just this business. So I was a very young programmer then, and I remember how of course that's all I knew. And now I'm thinking, man, this is touching everybody in some way, and it's another one of those inflection points.
Yeah.
So, but it's fun. It's fun. Well, Mark, thank you for coming on the show. If people want to catch up with you or follow you more, what's the best way to keep track of what you're doing?
Well, the easiest thing is just go to the blog.plur.dk, and I suppose you have a link in the show notes, so we don't have to spell it out.
Yep.
And you can find me. I think I removed more. I got tired of social media, so I removed all the SoMe links. But I'm on Twitter and Blue Sky and LinkedIn and Mastodon, and should be fairly easy to find. But otherwise, if you really want to follow me in any of those places, then just send me an email, and the address for that one is on the blog. So the blog is the entry point.
Sounds great. Well, Mark, thank you for coming back on the show. This is a great time. I'm glad to have you.
Thanks for having me. It was very fun.
Oh, my pleasure. And until next time, dear listener, keep shipping.
You've been listening to the AI DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.